The binomial theorem is a perfect example to show how different strings in mathematics are connected to one another. Its coefficients have combinatorial roots and can be traced to terms in Pascal's triangle. An expansion of binomials to different orders of power can be described probability and combination distributions. Mathematical induction is a method of mathematical proof used to prove an expression true for all natural numbers.
The steps are: first, state the proposition P of n that needs proving. Second, the basis. Show P of n is true when n is equal to 1. Third, the inductive step. First, assume n is equal to 1. Second, if P of k is true, show that P of k plus 1 is true. Fourth, if P of k plus 1 is true, therefore P of n is true.
First, let P of n be the proposition where P of n is equal to a plus b raised to n is equal to summation of n r is equal to 0 times n taken r times a raised to n minus 1 times b raised to r. The basis. Show P of n is true when n is equal to 1. Left hand side is equal to a plus b raised to 1, which is equals to a plus b. Right hand side is equal to summation 1 r is equal to 0 times 1 taken r times a raised to 1 minus r times b raised to r is equal to 1 taken 0 times 1 raised to 1 b raised to 0 plus 1 taken 1 a raised to 0 b times b raised to 1 is equal to a plus b, which is equals to left hand side. Therefore, P of n is true when n is equal to 1.
The inductive step. Assume n is equal to k. P of k is equal to a plus b raised to k is equal to summation of k, r is equal to 0. K taken r raised to k minus r multiplied by b raised to r. If P of k is true, then P of k plus 1 should be true. Left hand side, a plus b raised to k plus 1 is equal to a plus b raised to k multiplied by a plus b is equal to summation of k, r is equal to 0, k taken r multiplied by a raised to k minus r times b raised to r times a plus b is equal to a multiplied by summation of k, r is equal to 0, k taken r multiplied by a raised to k minus r multiplied by b raised to r plus b times summation of k, r is equal to 0, k taken r multiplied by a raised to k minus r multiplied by b raised to r
is equal to summation of k, r is equal to 0 times k taken r times a raised to k minus r plus 1 times b raised to r plus summation of k, r is equal to 0 times k taken r times a raised to k minus r times b raised to r plus 1 is equals to summation of k, r is equal to 0 times k taken r times a raised to k minus r plus 1 times b raised to r plus summation of k plus 1, r is equal to 1 times k taken r minus 1 times k times a raised to k minus r plus 1 times b raised to r is equal to summation of k, r is equal to 0 times k taken r times a raised to k minus r plus 1 times b raised to r plus summation of k plus 1, r is equal to 1 times k taken r minus 1 times a raised to k minus r plus 1 times b raised to r is equal to k plus 1 taken 0 times a raised to k plus 1 plus summation of k, r is equal to 1 times k taken r times a raised to k minus r plus 1 times b raised to r plus summation of k r is equal to 1 times k taken r minus 1 times a raised to k minus r plus 1 times b raised to r plus k plus 1 taken k plus 1 times b raised to k plus 1 equals to a raised to k plus 1 plus summation of k r is equal to 1 times k taken r times a raised to k minus r plus 1 times b raised to r plus k taken r minus 1 times a raised to k minus r plus 1 times b raised to r plus b raised to k plus 1
is equal to a raised to k plus 1 plus summation of k r is equal to 0. Quantity k taken r plus k taken r minus 1 multiplied by a raised to k minus r plus 1 multiplied by b raised to r plus b raised to k plus 1 is equal to a raised to k plus 1 plus summation of k r is equal to 1. Quantity k plus 1 taken r multiplied by a raised to k minus r plus 1 multiplied by b raised to r plus b raised to k plus 1 is equal to k plus 1 taken 0, quantity a raised to k plus 1 plus quantity k plus 1 taken 1, quantity a raised to k multiplied by b raised to 1 plus quantity k plus 1 taken 2 multiplied by a raised to k minus 1 multiplied by b raised to 2 plus k plus 1 taken 3 multiplied by a raised to k minus 2 multiplied by b raised to 3 until you reach the k plus 1 taken k multiplied by a raised to 1 times b raised to k plus k plus 1 taken k plus 1 multiplied by b raised to k plus 1 is equal to summation of k plus 1 r is equal to 0. K plus 1 taken r multiplied by a raised to k minus r plus 1 b raised to r left hand side. Summation of k plus 1 r is equal to 0. K plus 1 taken r multiplied by a raised to k plus 1 minus r b raised to r is equal to left hand side.
Therefore, p of k is true and p of k plus 1 is true. Therefore, p of n is equal to a plus b raised to n is equal to summation of n r is equal to 0 times n taken r times a raised to n minus r times b raised to r is true.